Okay, welcome to this workshop. This is a 3-day workshop. We will have the workshop going on every day from Monday, today, tomorrow, and the day after. It's from 5 p.m. to 7 p.m. And as part of the workshop, as you must have seen in the flyer, let me, Rajeshri, if you can share the flyer on the screen, that would be great. So as part of this workshop, as you can see, we have the list of the speakers who are going to talk about the different aspects related to life cycle thinking in terms of transport. That's what essentially the goal of this project for which we are doing this capacity building exercise. So this workshop is part of the capacity building exercise where we have to we're looking at the decarbonization of India's transport system. So that's the big picture. We're trying to look at the decarbonization of the India's transport system. So today, which is 20th of March, tomorrow we have 21st, and the day after 22nd. As you can see, we have a list of actually 7 speakers listed here. So I will start today with looking at, very briefly, I'll give you the introduction of what is life cycle assessment. Like what is LCA? So that's what I'll talk about. And then in the second, right after, and that will be around 35-40 minutes, then Dr. Ravi Shankar Chila will take over and he'll talk about how LCA is applied in the transportation sector. And which will be followed by, we have Mr. Sujit Samadar. He will join at around 6:30 or so. And he will be talking about potential for green hydrogen in Indian transport sector. He's a senior consultant with Niti Aayog. Ravi Shankar was a part of our research group here at IIT Kharagpur, and presently he is teaching at MVGR College of Engineering in Vijayanagaram, Andhra Pradesh. And tomorrow we have Rajeshri Bhar, who is presently a PhD student. Yes, the recording will be shared. The recording will be available on ITF website. The project was sponsored by International Transport Forum as part of OECD from Paris, and we will provide the recording to them, and the entire proceedings of this 3-day workshop, along with the PDF of PowerPoint slides and the reading material and this program details and biography of all the speakers will be available on their website, on the project website. Okay, so coming to on 21st of March, tomorrow we have Rajeshri who will give the overview of our project. What is this project that we have done with ITF? What was the major results so far? And then we have Dr. Sharad Gutikunda, who is also an alumni of IIT Kharagpur and has done PhD from US, I think Ohio State University, and or Iowa State University, and then he is the founder of Urban Systems, Urban Emissions, sorry, and he will be talking about his findings of as part of this particular project, like how the data is important, data resources for vehicle emission analysis is important. And then day after tomorrow, we have 2 prominent speakers, one coming from Curtin University, Australia. He will talk about some work that they have done on integrated framework to assess the sustainability potential of alternative fuels, a life cycle approach. That's Professor Wahidul Vishwas from Curtin University. That will be followed by Professor Biligiri, who is who is a department head right now in the Department of Civil and Environmental Engineering at IIT Tirupati, and he would be talking about applications of circularity in the pavement system. So that's what he's going to talk about. So that's in terms of what we are looking at. So that's kind of gives you the big picture of this particular workshop. I request you to join every day. It's not that you join only today and don't join there. And there will be an e-certificate provided. So you can, at the end of the workshop, those who will join all the 3 days will be actually given the e-certificate. So if you want to get the certificate, you should join all the 3 days. Okay. So let's get started so that we already have we are looking at 5:06, and we have until by 6 o'clock, 7 o'clock, we have to wrap it up for today's, because after a long day of work, 5 to 7, and after that, I don't want you guys to be hold on to, like, don't it may become delay for you. So that's so we will get started with our first set of presentation. So let's get started, and I would give you an introduction. Let me share my screen. So Rajashri, can I go ahead and share? Okay, so I think you can see my slides now, isn't it? So anyone just tell me whether you can see the slide or you can hear
Yes,
me.
sir,
Okay.
it is visible.
Okay, very good. So let's, so the first presentation, I'll give you an introduction to the life cycle assessment, because the life cycle thinking is what we have been using as a part of this particular project. So what is life cycle assessment? So just a very brief overview. And for the interest of the participants who are here, of course, there is a YouTube course on this particular topic as well. But we are also planning to come up with a set of videos specific for transportation sector, life cycle assessment in transportation sector. So that we will also make those videos for around 10-12 hours worth of videos we are going to prepare, and that will be available on the project website too. Okay, so introduction to life cycle. You already kind of know me. If you don't know me, just I'm Rajesh Dubey. I'm professor here in Civil Engineering Department, working in the area of circular engineering within our Environmental Engineering Management Division. I also head the School of Water Resources right now. I'm a chairperson for the School of Water Resources, and I've been working on different aspects of sustainability, circular economy, and all that. Now, coming to this particular life cycle thinking or life cycle analysis, why this thinking is important, why we have to start kind of focusing on life cycle thinking so much, especially in today's context. See, ultimately what we are trying to do, whether we are talking about this particular project where we are trying to decarbonize our urban infrastructure, which is essentially trying to reduce the carbon footprint of our urban transport system or urban infrastructure system or urban transport framework, like transport, it could be urban, rural, both. So what is the ultimate goal? Ultimate goal is to try to keep this planet as clean as possible, isn't it? That's so that our future generation can also enjoy the same benefit. So if you think about, when we think about the planet, we are thinking about this Mother Earth. So if you look at the age of this Mother Earth is around 4.6 billion years old. And out of that 4.6 billion years, if you take that 4.6 billion and put it on a 24-hour scale, let me get the pointer here, laser pointer. So if you put it on 24-hour scale, you will see that actually the Homo sapiens, the modern human, they have come here at 23, 59, 56 hours. So 23, 59, 56 hours is when the modern humans have appeared on this particular planet. So if you think about that, so that means what? 4 seconds. We have existed on this planet for only 4 seconds. If you take 4.6 billion years, put it on our 24-hour scale, 1 second is 52,000 years. 1 second is 52,000 years. So 4 seconds becomes 200,000 years. So that's what it is. 4 seconds is 200,000 years. Now, it's that in terms of that 200,000 years that we have been around, that's we have used up so much of resources. And not even forget about the 200,000 years. It's just last 200 years, or even within last 200, it is the last 50 years that we have used so much of resources and we have created so much of pollution. Our population has grown up drastically in last 200 years. And then in last 200 years, as the population has gone up, we have been using lots and lots of resources, and we are producing a lot of waste. So in terms of the human impact, if you look at the global impact, which is calculated using population times affluence times technology, which is also known as the IPAT equation, we have pretty much impacted biogeophysical system, biodiversity, natural sources, each and every aspect. As you can see, everything is in the red color. Everything is in the red color. So we have impacted each and every system there. So that's what, so we have to do better. We cannot keep on creating so much of pollution. And pollution, not in the sum of only solid waste, it's the emissions, the air emissions, the water emissions, the global warming, climate change, all are because of the pollution that we are causing. Presently, we use more than 50 kg per person per day, global average, more than 50 kg per person per day of material we are using on a daily basis. Out of that 50 kg, only 3 kg gets recycled, rest 21 kg is in use, rest of them just ending up in the waste disposal stream. So that a lot of waste going into the disposal stream. So we have to lost of, and that is also a lot of resources going into the disposal stream, isn't it? So we have to do better in terms of our environmental footprint. So there is a concept of ecological footprint, which also tells you the amount of land area or water required to produce sustainably the resources or ecological services needed to support a defined population at a set standard of living. So some countries, as you can see the example here, Vancouver, ecological footprint is almost 19 times its area. That means for supporting the activities that Vancouver does, or the Vancouver population does, the area required to support those activities is 19 times what is the area of Vancouver. Netherlands, 14 times the area. Australia has one of the highest footprints at 6.25 hectares per person. So in terms of other similar concept is what is known as the Earth Overshoot Day. Earth Overshoot Day essentially tells you that by which date you have used up all the resources that Mother Earth is providing you in that particular year. So if you look at the data from 1971 to 2002, which has been tracked, last year the data was, or the date was July 28, 2022. So July 28th was the date, the Earth Overshoot Day in last year. So on that day, we have used all the resources which the Mother Earth provided us in the year 2022. So whatever we used after in August, September, October, November, December is essentially we are taking things from the reserve. So that also leads to a higher ecological footprint, higher environmental footprint. So we have to do better. When we talk about sustainable development, this whole thing is kind of related to sustainable development. It takes to meet the needs of the present without compromising the ability of future generation to meet their own needs. We have to do better. Actually, we have no other choice. So that's where this whole concept of this decarbonization kind of starts. When we talk about this sustainability, sustainability has three pillars: environment, economy, and social. Environment, materials, biodiversity, energy, and biophysical interactions. That's your environment part. Society is your human diversity, equity, quality of life, political structures. Those are your society part. Economy is the money and capital, employment, technological growth, investment, market forces. Those are what is the economy part. So that's the reason. Like these are the three broader framework of like a bigger framework of sustainability has three pillars: environment, society, and economy. And when they all meet together, we call it sustainable. That's the sustainable system. So that's what we are striving for. That's what we want to make it happen. Government of India also came up with several programs focused on sustainable development. And one of the program was on the smart city program. If you look at the smart city program, we do have like energy management, renewable sources of energy, and energy efficiency, this urban mobility, water management, waste management. So a lot of things are there in terms of make things have a lesser environmental footprint. So this particular project is also focused on having the lesser environmental footprint. When we say decarbonization essentially means that you are trying to reduce the carbon footprint. So that's the whole process. Now, when you're trying to reduce the carbon footprint, how will you calculate? See, you have to quantify, you have to get the numbers, and how the numbers will come. So that number comes using the tool of life cycle assessment. So life cycle assessment is essentially a tool which we do in like an environmental accounting exercise, where we look at what is the environmental footprint of any product, any process, or any system. So here we are looking at decarbonization of the transport framework focused on fuel, the fuel that is used in our different like a fuel for your like a transport sector, whether petrol, diesel, biodiesel, hydrogen, or different types of fuel that we are. So which one is better? How much it is better? We are talking about electric vehicle. Is electric vehicle really better? What goes into making those electric like batteries for the electric vehicle? What is the environmental footprint of that? Well, how you are charging electric vehicle? When you are charging those batteries, how you are charging them? What kind of energy sources is being used to charge those batteries? And then what do you do with the end of life of that battery? How are you going to manage that battery at the end of life? So all those things has environmental footprint. So LCA, what it does is try to bring everything together to have a holistic picture. So you start from raw material extraction, material processing, part manufacturing, assembly, product use, and end of life. So if you take a very simple examples, I'll give you some simple examples, and then Dr. Ravi Shankar will take over and he will give you examples specific to the transportation sector. This is the first presentation as part of this workshop. The first lecture as part of this workshop is just focused to just get you familiarized with what is LCA. So we have kept it very simple. And towards the end, I will direct you to a course which is available on YouTube, which you can also look at. Some of you may have already looked at. So in terms of from cradle to gate, so if you think about a t-shirt, we all wear a t-shirt. Now, if you talk about the life cycle of a t-shirt, here you have eco-design happening in US, raw material coming from Turkey, production happens in US, sell happening in Europe, then finally somebody is using it in France, and that's an end of life. So from its eco-design product all the way back to end of life, if you can try to find out, how much, what is the environmental footprint, including all the transportation, raw material, energy usage, water usage, that's what we try to do. What is the footprint of this t-shirt? How much environmental what is the environmental implication was out there in terms of making of this t-shirt, and also in terms of when you don't how you dispose this t-shirt as well. So as an engineer or as a scientist, we design things. We design a lot of different kind of stuff. So the concept here in terms of decarbonization of the urban transport sector, actually the focus here is let's design the urban transport infrastructure in such a way so that it has lesser environmental footprint. So that's the overall goal of this project. So that to provide those tools and then incorporate our LCA thinking into the GREET model, which is out there. So things we design, create, consume, contribute substantially to our environment. So there are a lot of terms: sustainable engineering, sustainable design, design for the environment. So we move beyond carbon footprint or water footprint, and LCA is connected to the, like in terms of the environmental consideration. So LCA kind of helps in terms of these calculations. So if you think about any product, any system, you have a concept, you need material, you have to extract those material, you do certain manufacturing, you transport certain things, you retail them, you use them, you may have to clean it. If you're talking about some products being used at home on a daily basis, there's a disposal, and also recycling. The recycling actually should come before disposal, and then finally things does end up into the environment. So we have to have what is known as systems thinking. System thinking does get complex. So we have evolved a scientific process so that people sitting all over the world, anywhere in the world, they should be able to understand it. So if I do LCA sitting here in India, somebody doing LCA sitting somewhere in other part of the world, we should be able to compare our LCA within the certain boundaries, within the certain limitation. So that's why we have an ISO standard. So there is an ISO 14040, 14043 that's essentially is a technique for assessing the environmental aspects and potential impact associated with a product, system, or service. So that's what we do. How it helps. See, in this particular project, as you will hear from Rajashri tomorrow, that they are from even Professor Wahidul Viswas will talk about day after tomorrow, and the other speakers will talk about things too. See, it does help in the decision making. See, how are we trying, when we are trying to decarbonize, is it really helping in decarbonization? How much it is helping? It also helps us to do better communication, like in terms of better communication to for labeling, for the product declaration, and so on and so forth. Also, learning, identify improvements. Sometimes you also look at in terms of the liability of future. So those things are also taken into consideration. So again, just to kind of give you try to keep your attention intact, I introduce this picture right now here, just to kind of grab your attention that why this LCA thinking is important. See the top picture, as you can see, this gentleman is driving a diesel vehicle and he feels so dirty because of all the exhaust that is going on. He goes out and buy an electric car and he feels very clean, but the electric vehicle is getting charged using the coal-based thermal power plant. So what is happening here? Is it a good move from here to here? To some extent, it is solving the urban air, urban air emissions on the vehicular air emissions. Of course, will get improvement if you're using electric car. But overall, what is happening? We are shifting the problem from the cities to this power plant now. We have to generate more electricity to power, to fuel, to charge these batteries from this electric car. We have to produce these batteries. So more mining activities, and then those have a lot of environmental footprint as well. So your environmental footprint will go up in terms of mining activities to get all those critical minerals and other stuff to produce the electric vehicle batteries. And at the same time, you will also, if you are charging using the coal-based thermal power plant, so that you are again you are creating carbon and more like a carbon footprint, because more energy production using fossil fuel, more CO2 emissions. So whether moving from diesel to electric is going to help, answer is yes with it, but in those scenarios it will help when we have more and more renewable energy being used for your battery charging and all that. If you keep on using fossil fuel, it will not help you that much. It may help you a little bit, but when you incorporate all the mining activity that goes to make those batteries and all the things that will go associated with that, you may find that it actually of not that much of a benefit. You have, although it will feel good, but real impact, overall impact may not be that much. And we have, based on our studies, what we have seen, that you need at least 60 to 65% of the energy source being the renewable energy, then only it is going to make sense. And at the same time, the renewable energy components as well, the solar panels and wind, those wind tunnels and all windmills, they should also be managed responsibly at the end of their service life. If you don't manage those waste properly in the end of the service life, your benefit will be even lesser. So that's what we need to look at. So now, very simple, some examples just to give your attention. How life cycle can be applied in a very small things. Then we will go to the transportation sector when Ravi will share some of his examples. So in terms of what is better among these two, say one, of course, if you just compare one of these versus one of that, this will come out to be better. This will be a lesser environmental footprint. But this gentleman, if you keep on using it again and again, this comes out to be much better. So similarly, these two, we know that CFL is better, isn't it? Now we have to put LED as well, and we can find out which one is even better. Is the LED even better than that? Among these two, which one is better, plastic bags or a paper bag? So I'll request the participants if you can mute yourself so that we don't have background noise. Rajashri, you can mute. You can also individually mute if needed. So in terms of what's better, whether this paper bag or a plastic bag. So in general, see, we moved from paper bag to plastic bag. That was the plan. That there was the thing. If you do a life cycle assessment of an individual bag, actually, or the manufacturing process, paper bag actually has a bigger environmental footprint. So what is the problem? The problem is we are not managing the plastic bag properly. The plastic bag is not being managed properly. It is creating a lot of environmental nuisance. That's why we are actually trying to now go back from plastic bags to the paper bag. So these two cars, of course, Prius is better than Hummer. We don't have to. So this is in terms of LCA activity, the life cycle analysis thinking. This started long back in 1969 when Coca-Cola company wanted to know in terms of whether they should go for a plastic bottle or a glass bottle. And the lower weight of plastic bottle actually reduced the energy needed to sip the bottles. Glass was heavier, more breakable than plastic. And then at that time, Coca-Cola had started a plastic recycling plant for their own plant, and it was become easier for them to manage it. So on that particular scenario, actually they found out to be the glass bottle was actually plastic bottle was better than the glass bottle. So, and see, again, you have to look at the context. You have to look at the system boundary. You have to look at the functional unit in terms of these stuff. So in terms of life cycle, it's a compilation and evaluation of input, output, and potential environmental product or product system throughout its life cycle. There are ISO standard, International Organization for Standardization. What can we do? We can do the product improvement, planning, public policy making, marketing, and eco declaration. So this is how we do LCA. There is a goal and scope definition, inventory analysis, and impact analysis. So here we look at what is the unit selection, energy mix, where in the world we are doing it, what kind of energy mix it has. We do inventory analysis, what energy material in and out, impact analysis, and then finally interpretation. So you start from raw material acquisition, your material energy coming out, waste coming in, waste coming out, material processing, manufacturing, use and service, retirement recovery, then finally treatment and disposal. For each of those processes, you get material and energy input and the waste output. You consider reuse, remanufacture, closed loop recycle, open loop recycle, and then you come up with your overall product life cycle. So as I told you earlier, started in 1979, but then nothing really happened until 84, when in Switzerland, the packaging thing started. Then CTAG got involved, then ISO standard came, then we have now UN, CTAG, Life Cycle Initiative, European Platform, Eco Invent Center, all those things are there in the picture. So what makes up an LCA? We first have to come up with a goal and a scope. What is the purpose of LCA? Who is the audience? Then we do inventory analysis in terms of what is functional unit, where are the boundaries, what data do you need, what assumptions are you making, are there any limitations? Then we also go for impact assessment. What are the environmental, social, economic effects? We go for interpretation, like how to reduce the environmental impact, what conclusion can be drawn, what recommendations can be made, and so on and so forth. So if you compare a very simple comparison in terms of goal and scope, wooden pencil, compare two writing utensils. So you can see the process flow diagram. So lumber forest, lumber mill, your manufacturer, retailer, use, end of life. You use rubber, use graphite, your packaging, you have transportation in between. So the entire thing has to be taken into consideration. Same thing for mechanical pencil. You will take oil, then rubber, graphite, packaging, spring, manufacturer, retailer, and all those things has to be taken into consideration. So as I told you earlier, in terms of inventory analysis, first thing is function and functional unit. So what is the function? To write, isn't it? That's the writing. Functional unit, we can say 1 meter of writing, 10 meters of writing, 1 book worth of writing. And so we have to give a number. And then we compare based on that number. That becomes our reference point. So what is needed to make the substance? We take all the energy, material, labor. What is the output in terms of product, waste, emissions, co-products, and all that? We collect data, time stamp data, geographical data, best technology available, representative data, consistent reproducibility data. And then we also don't forget about precision and completeness. So those things are also there. So then once we have this data, we try to look at the environmental impact. So in terms of global warming potential, in terms of abiotic, human toxicity potential, eutrophication, acidification, and there could be many more. So we look at what are the different impacts that can potentially have from the process. Now, what we do with all that? What is the purpose of all this data? We can make recommendation of choices that are less impactful. We can analyze a particular impact, focus on a solution. Industry and individual can take a closer look how they make a difference. And so there are different tools out there. We have SEMA Pro, we have an LCA calculator, we have an open LCA. Those tools are available. And there are also some courses, like there is as I told you earlier, there's a course available on this particular topic where we talk about sustainable engineering concepts and life cycle analysis. This is an 8-week course. It goes in great detail. And we will prepare a small version of this course for this project, around 12 weeks worth of a course. We'll prepare, and that will also be part of this project, will be uploaded. So this course is offered every year in the month of July, August, July time. This course gets offered, and it's available online. You can go on YouTube and search for this course. You will find it. And so thank you.